Hello again, beautiful people. Welcome back. Right, we are still looking at integral calculus, and particularly today we are looking at the area bounded by the x-axis and the boundaries that we are given. The area under the graph that's bounded by the x-axis, or the area between the graph and the x-axis. Right, the second example, we want to look at the following example. Now, this is, if you were following me and you were here when we did the first example, this is going to be a little bit different. Here's an example. Find the area between the curve and the x-axis for the function y is equals to x squared plus 3x. Between x is equals to -1 and x is equals to 2. The first thing to do always when you are given a function is to always try and do a free body diagram. Try and draw that function. Try and see what it looks like so you can have a visual picture of what you are working with here. Okay? Right. So let's do that now. I'm just going to move the board a bit to the right just to get more surface area to work on. So we want to find now y is equals to x squared plus 3x, and this area is also between x is equals to -1 and x is equals to 2, and this area is bounded by the x-axis. Let's draw the graph first. Before we go anywhere, let's draw the graph first. Right, sorry about that. Right, there's my Cartesian plane, that's my y, and there's my x-axis, that is my origin or my vertex. Right, so let's draw this. Y is equal to x squared plus 3x. I know that's going to be a parabola, okay, from my previous studies. We know that. What's your x-intercept? You let y be equals to 0. So if you let y be equals to 0, then we're going to get x squared plus 3x is equals to 0. Factorize that, you get x plus 3 is equals to 0. So you're coming up with two intercepts for x here. The first intercept is going to be x is equals to 0, and the second intercept is going to be at x is equals to -3. 0 is here, so the graph is going to cut through the origin, and -3 is, we are going to estimate it's going to be there, so the graph is going to cut through the -3 x on -3 on the x-axis. Now this is a parabola. I know that this is going to be a smiley face graph because my coefficient is positive. I know that. The graph cuts here, the graph cuts there, and it's a smiley face. Okay, so I've got a curve that goes like this. I'm not too worried about my y and turning point or whatever. I just need to see the shape. Remember, I'm only asked to find the region between bounded by x is equals to -1, between -1 and +2. So all the other nitty-gritties for now I'm not too worried about. Let's go back to the question. So in the question they said, so that's the graph, there's the curve. Now which region are we looking at here? Between x is equals to -1. So if this is -3, I'm going to set my -1 to be there. And x is equals to 2, I'm going to set my 2 to be there. I'm going to draw 9 straight vertical lines passing through these two boundaries at +2 and -1, such that I now have, and remember that these regions are bounded by the x-axis as well, such that now I have that little area there. Okay, that's below the x-axis, and I also have this area bounded by x is equals to 2 and the graph which is there. Now, unlike the first example, in the first example I had two regions which were, I had two boundaries. My upper limit and my lower limit were both positive x. That's the first thing. Excuse me. And the second thing is that my upper limit and my lower limit formed an area with the graph that was produced under the x-axis. But in this particular example, I've got two regions for my area. I have got one area that's below the x-axis. I've got another area that's above the x-axis. So how are we going to do this? Yeah, you guessed it right. What we are going to do, we are going to separate these two areas then. We can't combine them. So we are going to have two boundaries. We are going to look at first this area here with boundaries -1 is less than x, which is less than 0. So we are going to take consideration of that boundary first. And the second one is we are going to then do the same integral, or take the integral to determine this area between 0, it's less than x, which is less than 2. So we are splitting it up. Let's call this area 1. And let's call this area 2. So in our integration as well, we are going to split them up. You can call them area A or area B, area P or area P, but just separate them, split them up. Right, now, it's working it out. If I want to find the area bounded by the graph and some kind of an axis, I know that I'm going to take the integral. I have got the equation there, or the function of the graph itself. So area 1 is equals to the integral between 0 and -1 of x squared plus 3x dx. And that's my first equation set up. Now, the next thing is I'm going to take the integral of that. Remember, when we are integrating, just to remind you again, we add 1 to the power, we divide by the power. So area 1 comes up to be, we don't write the integral sign anymore because we are integrating now. So you write a big square bracket. Inside your square bracket, add 1 to the power, that becomes x cubed, divide by the power, divided by 3. Plus, add 1 to the power, that becomes 3x squared, divide by the power, divided by 2. And close that. It's a definite integral. Put your boundaries, your upper boundary at the top, your lower boundary or your lower limit at the bottom. So that's, we've integrated, and that is going to give us our area 1. Work that out. That's going to come out as 0 if we substitute that into there. And the second one, if you substitute -1 into that, that is going to come out as 7/6. So we've got 0 minus 7/6. So area 1 is equals to -7/6 units. Again, just to take you back to what we said in the first example, if your area is below the x-axis, your integral will come out as negative. That area there, area 1, bounded by -1 and 0, came out as a negative. That tells us that it's below the x-axis. Okay, so we found area 1, it's 7/6 square units, but we want to find the total area. We want to find area 1, and we want to find that area as well, bounded between 0 and 2. We repeat the process. So for area 2 is equals to the integral. Our limits now become 2, our upper limit is 2, our lower limit is 0, of the function x squared plus 3x, and we are integrating it dx. Integral rules, add 1 to the power, divide by the power. Area 2 becomes square bracket x cubed divided by 3 plus 3x squared divided by 2. Close your square bracket, put your limit, and then substitute in your limit into your equation, and you will find that your answer, if you substitute 2 into the equation minus 0 substituted into the equation, that's going to be 26 divided by 3 units squared, or squared units. Now, Remember that in area 1 came up to be minus 7 over 6 square units. We ignore the negative because we are looking at area. Area is a scalar quantity. We do not make area a negative. If you say it's minus area, it's the same as you are minusing. If I ask you what's the time and you say it's minus 5 past 2 or minus 10 past 7, you cannot have a negative area. Okay, so the area therefore there, area 1 is equals to 7.6 units that are square or squared units. The total areas then, the rest as they say is maths. The total areas then, to find the total areas, all I have to do is area total is to add area 1 plus your area 2. So your area total becomes 7 over 6 units plus 26 over 3 units. And your total area is 59 divided by 6, 59 over 6 units squared. And that is how it's done, folks. Thank you very much for watching and for listening. I will see you next time, same time and same place. Thank you very much. Bye.